Great, well thank you. Excited to be back on stage. Now we're going to shift gears and talk about security. There's a couple different security topics that we're going to go into. I will focus on platform security, specifically how to create a secure Hadoop environment. And one of my colleagues will join me on stage to talk about cybersecurity and how we can use Hadoop to combat other security problems that exist outside of the core Hadoop platform. I'd like to start with a slide that I found in a keynote presentation from a previous government forum. I think it was last year's government forum. It was a keynote by Mike Olson, Cloudera's co-founder and chief strategy officer, in which case he went into some detail about different use cases related to public sector and Hadoop big data use cases for public good. And he concluded the presentation with this slide, talking about the future of government is data management, and what's your strategy? I found this to be a very compelling argument. Essentially, we've seen in the commercial world that big data and the technological innovations of Hadoop have enabled significant business transformations, enabling corporations to become much more data-driven. And his argument, and I think it makes perfect sense, is that governments are doing the same thing in the public sector. So empowering individuals and agencies to use data to analyze, to reach insights, to make decisions, and overall provide better government. Now, as we've talked about a few times already today, the platform that we use to make this possible is Cloudera's Enterprise Data Hub. This enables you to bring all of your data together, breaking down physical silos, replacing them with logical silos, controlled by permissions, allows you to bring all of your knowledge workers together, having multiple workers working together to process, model, serve, and analyze data. And it's not just Cloudera, it allows you to bring all of your applications together, all in one open ecosystem, running anywhere, whether it's in the private cloud, public cloud, or traditional on-prem data centers. So that's the technology we use to do this. From a security perspective, we can look at this slide and see perhaps kind of a different outcome of that. And that is that in EDH, it also makes kind of a nice target, right? If you've got a place where you can bring all of your data together and enable all of your workers to have access to that data, well, there's some business benefits that you can get out of that, but there's some potentially security risks as well, as I'm sure you can imagine. So what we're going to go into in detail here today is how do we take a methodical approach to providing holistic security, looking at it from all the different angles, and sharing our best practices with you. So as mentioned, there are a few different aspects of security. We look at these perimeter access, visibility, and data as the four pillars of security. And we feel that it's important not just to have some capability in one or two of these areas, but you need to have strong capability in all four areas in order to have a truly secure Hadoop environment. There's a number of different things. We'll go into the details about the technologies and the requirements, but overall, as you're building out a strong solution, there's a few key things to look for. First is that it should be proven technology. So it's one of the things we've focused on over the last few years is not just putting out new technologies and new tools, but getting them, working with our customers to get them live in production, stabilized, high availability, et cetera. So proving the technology in production deployments is a critical part of any solution. Making sure that it is ready for all the multiple environments that you might be running in, whether that's on-prem or cloud. So making sure that the same technologies work in all of your environments is important. Third is that it should be a uniform solution. In other words, if you're going to have certain kinds of authorization capabilities, it should work uniformly across all the components and not have to have completely separate solutions for different areas of the product. And third, it should provide you an appropriate level of depth. It's one thing to just deny access to everybody. That's a form of security, but not a terribly useful one, right? So you need to be able to have the concept of the principle of least privilege. Give people access to what they need to be able to do their job and no more. And we're going to talk about how our product suite helps cover off that principle. And finally, it needs to be tightly integrated with the product. This is something that, in other areas of the product, Cloudera is inclined to partner, right? We're not trying to deliver everything that you might want out of the box. So whether it's visibility tools, UI tools, certain kinds of integrations that we partner with a lot of different companies to bring more value to the ecosystem. In the area of security, we feel that it needs to be tightly integrated to the platform that helps eliminate integration issues and extra shopping cycles that a customer might have to go through just to get a secure solution, which is sort of a first principle out of the box, needs to be there and be available. So let's look at these one at a time. For perimeter security, we're dealing here with the concepts of authentication and network isolation. Authentication is essentially confirming that the user is who they say they are, and network isolation is providing access only to the parts of the cluster that an individual really needs to have access to and no more. Now the key technology that we use to do this is Cloudera Manager. It sits and kind of controls the permissions, integrates with your existing standard systems, whether that's Active Directory or Kerberos or LDAP or other environments. It is the sort of central point, and that's key for the InfoSec team, is that they don't want to reinvent the wheel. They want to leverage their existing systems they're using across their entire organization. They want Cloudera to conveniently plug into that. From an end user perspective, they just need to have access to what they're trying to get access to. They don't necessarily care about the technology. So a good solution is going to be quite transparent and easy to use for the end users while being standards compliant for the InfoSec team. If we look at authentication, we can see there's a few different components where users will require authentication to access. First is all of the CDH components, Hive and Spark and MapReduce and all of those. Here our primary technology is Kerberos, and as I said before, that is going to be managed by Cloudera Manager and pulling out of the Active Directory, out of Active Directory. For the web UIs, we have a couple other technologies, LDAP and SAML authentication, and for SQL access, it's LDAP and Kerberos. Overall, confirming the user is who they say they are before they're able to access any of the individual components within the overall Hadoop environment. So a comprehensive solution there. From a network isolation perspective, we have a concept of splitting the cluster into sort of two levels of access. It's kind of a two-tiered firewall approach. Most users, the business users, the analysts, the data scientists, they only need to access generally the gateway services. And we position these strategically to run on the periphery of the cluster. So these would be web servers or edge nodes, and we grant access for generally most users to those nodes, but that is not where we store data, that's not where things are administered and security policies are defined, such that there's not a whole lot of mischief that most users would be able to do only on the edge nodes. And for the full cluster, where we do store the data and where we manage all of the administration and security capabilities, well, that's going to be an admin-only configuration. So we split the network, we split the Hadoop environment into two levels and grant access only to the level that you need to have access in order to do your job. Moving to the second category, for access security, the key concept we're dealing with here is authorization. So once we've proven you are who you said you were, now the next question is, well, what data are you allowed to access? And it's not just what data, but what can you do with it, right? Do you have access to all of the table? Is it read-only? Can you write? Can you insert? Can you join? What are the key capabilities? And do so in quite a detailed level. Here, the key technology we're going to use is Apache Sentry and Record Service as the two capabilities providing authorization controls throughout the platform. Here, the end users, again, they just need to get access to whatever data they need to do their job. And from an InfoSec perspective, they want to enforce the concept of least privilege for all of their users. Only provide access to the data that each user needs and no more. So let's walk through an example of what this looks like. Back in the olden days, in the early days of Hadoop, before there was a whole lot of capability in terms of authorization controls, you essentially only had storage level permissions. In other words, you would create files, and the file system itself would provide kind of all or nothing permission based on a file. So, as an example, certain users can access the green files and other users cannot access the red files. This works okay. It's sort of simple, it's standards-based, it meets some of the criteria, but it is insufficient in that tables often contain a lot of data, right? They contain tens, even hundreds of columns. Some of those columns you may or may not want to share with all of the users. There's lots of reasons why you might want to place some restrictions. In particular, if we look at columns, different user groups, it's quite common that you would only want to provide access to certain columns. For example, if you have a record of employees or other persons of interest, and one of the columns is social security numbers. Well, there's probably somebody in the organization that should have access to that, but there's probably many people that should not have access to the social security column. Maybe other columns would be similar. From a row perspective, again, you have the idea of different records should be accessible to certain people, but based on security clearance level or other hierarchical or organizational structure, you may want to restrict access to some of those records. In a corporation, this could be salary information as an example. So moving on to how we do that. So I mentioned before we started with simple file-based storage permissions. We then added SQL authorization. This adds column and row level permissions, but it can cause scenarios where you might need to duplicate the data. And here specifically, our storage plus SQL works well for Hive and Impala workloads. This is the SQL primary engines, but MapReduce and increasingly Spark are popular as well. And in order to achieve the same level of control for because we don't have, let's say, native authorization controls for Spark and MapReduce within Apache Sentry, you have to split the table. So in this case, if you identified that group 1 should have access to the red columns and group 2 should have access to the green columns, you would have to duplicate that data and duplicate the permissions rules in order to provide access to Spark and MapReduce. So this was the previous state, and what we're moving towards is sort of full column level and row level permissions with detailed provided by Apache Service and Record Service. Apache Sentry and Record Service. Record Service being in beta now and moving towards GA roughly by the end of the year, in that time frame. This will allow you to have one copy of the data and only one set of permissions so that you can have true column level and row level permission controls. Okay, and just to graphically see what that would look like, suppose you had the table on the left here where you have a lot of different information coming from different countries, and you wanted to have sort of a geographical based permissions set up where the people in the US can access the records in the US, so on and so forth. Without Sentry and Record Service, you would need to duplicate all of that data. So you'd create a separate table just to contain the US data, and so on and so forth for the EU data and the UK data. With column and row level permissions, you can maintain all of that just through the permissions. You keep the one copy of your data, and you create a few permissions rules to say, okay, my US users get access to the US data within that existing table. So much more efficient, much more manageable, and sustainable security policy. By sustainable, I mean that as you add in new services and new users, you don't want to have to go back and think, okay, what rules have I duplicated in the past, and what rules do I need to continue to duplicate as I create new users on the cluster? The third pillar of security is visibility. And here, some of the key technologies that we're looking at, key concepts, are auditing and lineage. Lineage is most important to the end users. So end users want to know where did the data come from, who's been using the data, and what are sort of the original sources, how it's been modified, and even things like what other kinds of data types are similar to this data. I would like to be able to discover other data sets that match what I'm looking for. Lineage helps with all of that. From an InfoSec perspective, they want all of that. They want lineage as well, because sometimes whether they're implementing governance policy or aging out older data, seeing what data is used, what data is duplicated. In addition to the lineage, they also want, in fact, require true detailed audit capabilities. Whether it is compliance information or it's healthcare industry and you have HIPAA or other sorts of regulation, it is very common that sensitive data needs to be fully auditable. And you need that not just on this user access that table, but specifically which rows, specifically which columns. These are the key requirements for a complete audit solution. The key technology we use for this is Cloudera Navigator. And Navigator, for those of you that maybe aren't familiar with it, there's really nothing like it out there in the Hadoop environment that's similar. It's sort of, let's say, far ahead of the competition. It's growing very quickly within our customer base. We have hundreds of customers using it, not just for sort of basic, step one kind of data governance, but using it for full audit, lineage, and data discovery capabilities. It's growing very fast in terms of popularity within our customer base, and we are continuing to invest more and more in that technology. It provides you detailed column and row level access trails, as I mentioned, which is required for audit. And one of the key reasons for its popularity is that it plays nicely with other platforms, other software that runs into that. So we have a lot of plugins where people can produce their own metadata and then make that metadata discoverable to Cloudera Navigator. Similarly, the lineage trails that Cloudera Navigator is able to uncover, it's able to expose to those other tools, so you get a much more seamless and integrated experience. So a very powerful tool in Cloudera Navigator. The fourth pillar that we're going to talk about is data security. Here, the key requirement's pretty simple. You're dealing with regulated data and you want to provide analytics and other kinds of data processing capabilities on that regulated and highly sensitive data in some cases. So that's fine, that's what we're here for, but there are some rules and best practices about how to do that. The key concepts we're going to deal with here are encryption, key management, and data masking, different ways of protecting the data. And I'll go into some detail about how we do that. From a technology perspective, you've got HDFS encrypt, Navigator encrypt, and key trustee as the key Cloudera tools that enable this. In encryption, I think one of the main things to focus on here is that it needs to encrypt all the data. Okay, so there's sort of multiple ways of looking at that. First is you have data on the wire and data at rest. So you can set up TLS or other forms of data in transit encryption. All of that should be provided by the system out of the box. And for data at rest, I think it's relatively obvious that you want to encrypt the HDFS data, but there's a bunch of other sources and repositories of data in and around the platform that sometimes can be overlooked. Things like temporary files and ingest paths and log files and sort of other copies of the data, whether that's in HBase, Kudu, etc., where you might have other elements of the data. So a good solution needs to provide encryption for all of that, make it simple and available out of the box. Second is key management. So your encryption policy and strategy is only as good as your key management policy and strategy. Here, whether you're managing the keys yourself or you're using a hardware security module to manage that, we have a lot of deep integrations with that. Automated key replication and backup to keep your keys safe. If you lose a copy of your keys, you lose your data, so that's not good. And then, as I mentioned, you can back that on HSMs. And finally, perhaps often overlooked, but data masking can in fact be one of the most secure ways of securing the data. This is essentially redacting data before you even write it anywhere. So if you've got some data that you're never going to need access, let's say, to the full social security number, and you only need the last four, let's just eliminate those first few digits as the data comes into the platform. Same for storing data in log files, config files. Let's just mask all of that, redact that data before you put it anywhere where somebody might be able to break encryption later on and do something. So overall, what we've talked about here is a comprehensive, compliance-ready security solution addressing these four pillars. A number of different technologies there. As I mentioned, you're looking for proven capabilities. They should work consistently across environments, whether that's on-prem or in the cloud. They need to have the right level of depth. Table only is generally not going to be sufficient. It needs to be row and column only, and it needs to integrate with standard tools, including being tightly integrated within Cloudera Manager. So that's the portfolio that we have attempted to put together and provide with Cloudera Enterprise. If we think a little bit about sort of what's next, what can we do if we go beyond security controls? there's a couple of interesting ideas out there. I think taking the concepts of automation, some of the artificial intelligence concepts that our colleague from Intel just shared, there's some interesting things that can happen here in the area of security. As an example, if we can train the system to look for sensitive data, it can automatically discover and tag that data. You could then apply automatic security policies. Anytime you ever see a social security number, here's how I want to treat that. Anytime you see certain persons of interest, here's how I want to treat that. And the system can do a lot of the work for a security administrator automatically. This would apply for authorization and encryption policy rules. A related approach is a follow the data authorization and protection policy. So you have a concept of setting up authorization rules associated with certain data as opposed to with certain users. It's kind of flipping the use case around a little bit, and then leveraging some of the lineage capabilities to enforce authorization and encryption policy. This could go a long way to eliminating manual configuration of security. The admin has to remember, okay, a new data set arrived, I need to go set up some new policies, I need to refresh my policies. Are they up to date, or did they get out of sync somehow whenever you built the cluster? A lot of that can be eliminated if you automate some of these things. These are areas that we're investing in. We're researching, what are practical ways to deliver strong value to help go beyond those 4 pillars and enable tighter, better, more automated encryption. And our goal here would be that admins would be focused more in the future on exception handling. The system worked, but maybe it locked a particular user out of some data that they probably should have had access to. Now let's go in and figure out how to give a little bit more permission to those users, as opposed to starting with a completely open system that they're constantly looking for ways to try to secure that. So thank you for the time. I have some extra time, actually, if there are any questions that I can cover. Okay.
What examples of plugins do you have for Navigator?
Oh, let's see. The question was, what are some examples for plugins we have for Navigator? I don't have a good list. I don't want to just. I know it's either Trifacta or there's a couple other ones. There's a few that are looking to provide, let's say, more consistent metadata above and beyond what we have. So I don't remember the exact names, unfortunately. Okay. Thank you.